Hello everyone, I'm Paul and today we're solving problem 2145, count the hidden sequences. So we're given an array with differences between consecutive numbers, and we're also given two values, a lower and an upper. And our job is to return the number of hidden sequences that we can create such that every value in the sequence is in between lower and upper. So let's see what this means. Let's say that the differences array is this one, and low is 1 and upper is 6. So in this case we could create two hidden arrays, which are 3415 and 4526. So given that we can create two hidden arrays, the result for this one is 2. Okay, so now we will go with how can we solve this. Now let's say once again we have this array and these are the bounds, lower and upper bounds. So the first thing we want to do is to create a hidden array starting with the value 0. Okay, and from here with the differences we will create this hidden array. So 0 plus 1 is 1. 1 plus minus 3 is minus 2. And minus 2 plus 4 is 2. Okay? So the maximum value for this one would be a 2. And the minimum value would be a minus 2. So given that the minimum value is smaller than our lower bound, this hidden array is not valid. But let's see the following. Right now we have a hidden array with these values here. So 0, 1, minus 2, and 2. And we know that this one is the maximum value and this one is the minimum value. We also know that this is the lower bound and this is the upper bound. And another thing we know is that the differences in this array are correct because we have built this using the original array of differences up here. Okay, so if we take the difference between the upper bound, which is 6, and the maximum value, we have a difference of 4. And if we take the difference between the minimum value and the lower bound, we know that here we have a difference of 3. So to find the answer, we only need to do 4 minus 3 plus 1. Okay, let's see why. Let's say that we want to create a hidden array which has the maximum value right in our upper bound. Okay, so let's do that. So here is the new hidden array and the maximum value would be here, right in the upper bound. And the minimum value would be here. So the difference between the minimum value and lower bound, which is 1, is 1. So we know that we have one valid array, which is this one. Okay, so this is valid because it's in bounds. It's in between 1 and 6. Okay, 6 and 1. So how many more arrays can we add to our result? Well, the answer is the minimum value in the array minus the lower bound. That's how many more arrays we can add to a result. And that's why for the result we only need to do a small formula, which is upper minus the maximum value minus lower minus the minimum value plus 1. Okay, so we just need to get the difference between upper bound and the maximum and the difference between lower bound and the minimum, which is 1 in this case. We want to subtract the upper difference minus the lower difference and add 1 to that, and that's the result. So in this case we'll have hidden equal to. Time and space complexity for this one will be big O of n. So now let's go with the code and hopefully you will get the idea. First we will create our hidden array, initially with a value of 0. Here the value is not important. You could start with a 5, a 7, a 9, a 2, whatever. But we'll start with a 0. And now we will build this array. So for the indifferences, hidden dot append the last value at hidden plus d. Now we'll get the minimum and maximum values. So minimum of hidden and the maximum of hidden. And now we'll say our result is, as we said before, upper minus the maximum minus lower minus the minimum plus 1. And if result is smaller than 0, that means that given the differences array we have here and the lower and upper bounds, we will never be able to create hidden valid arrays. So here we can return result if the result is greater than 0, else we want to return 0. And this is the entire code, so now we'll see if this works. And as you can see here, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.